Hi and welcome to LogScope. We're loading LogScope up and we're loading a LAS file called Barina2, and we're going to show you how to edit this data. The data is in feet, so we're changing it to meters, and then we're going to change the scale to a reasonable scale of 1:500. The first action we're going to undertake is what's called topping and tailing the logs. So let's go and find the top of the log. The top of the log is about 1070 meters, so here we are at the top of the log. As with all operations in LogScope, you select the curve by simply clicking on it. We're removing one of the resistivity curves, and we're removing one of the sonic curves, as you can see here. Okay, the next operation is that we're actually going to get rid of the casing effects at the top of this log for all the curves. So let's start with the resistivity curves first. So the first thing we need to do is we click on the curve and then we select patch, and then we change it to erase, and then you tap once, then you tap twice, which designates the top and the bottom, and that erases the curve, and the screen updates to show the curve being erased, and then we hit process. Then we go back up to the top of the screen, we select the next curve, we hit patch, we select erase, and we repeat the operation. And then we do the final curve. So it's patch, and then we select the erase button, and then we tap at the top and tap at the base, and then process. We're going to continue with the erasure of the casing effect on the sonic. So we go to the top of the screen and we hit patch, and then we tap it into erase mode, and then we tap the top and the base and then hit process, and that erases the sonic for that. The next step is to do the SP curve, and firstly we're going to change that SP curve so that the color is something that we can actually see. So let's just go and do that now, and you should see the cursor move up, highlights the SP curve. We select edit, and we select the color, and we change it to black, and then OK, and it automatically updates in black. So we then go back to the patch, we change it to erase, and then we delete that particular point, that particular casing effect at the top of the curve, and then we hit process, and that's done. We scroll down to the top of the neutron density, and we note that the neutron is in percentage, i.e. 14%, instead of in volume for volume numbers such as 0.14, and we can see that when we look at the data and we actually scroll through. So LogScope has the ability under functions to change the units. So we go into there and we go to the unit changes, and we select for the X log the neutron, and we select for the Y log the very same neutron, and then for the output units we change it to volume for volume. LogScope has an extensive unit database, and you can change it, and once it's done, this is the result that you get. Okay, we use a linear function, and for the first thing we do is we need to add a new set, and we're going to pre-populate this with the default, but we're going to change the bottom depth to 1068.42 meters. This will create an additional set in LogScope that just covers that top interval. So then we'll give it the name of gamma ray corrected. So it creates that set inside. We want to change the MX, the M value, and then we're going to change the input curve to gamma ray, and the output curve we're going to make a new one, and we do that by just pressing the plus button, changing it to the output group gamma ray, and we're going to make it the gamma ray, and we're going to give it GAPI as the units, and gamma ray, okay, and then run. The final step is to use the merge, and merge has the ability to merge just individual logs. So we select the gamma ray, and we're going to select the gamma ray from our computed gamma ray that's been elevated by 1.5, and then we're going to select the main log as the output, and then we're going to specify not the top depth but the bottom depth, 10468.42, and we're going to merge it in. And because LogScope is graphically oriented, you will see the merge take place immediately after we execute this command. And there we have a data set that's edited. We're now going to do an SP drift correction, and the first thing that we do is that we're going to change the SP so that it's scaled -100 to +100. So this is done by simply selecting the limits on the curve properties, which is done by selecting the curve. Note that it's highlighted in yellow, and you can actually select the actual values, and we work our way through. So let's get these to -100. So there it is, -100, and the other end is now 100. And then we hit the OK button. So now the curve has been adjusted, and it's still highlighted, and we can access the shift underneath, or the SP drift correction underneath shift. It's given a generic name because you can apply this to any curve. So if you've got a curve on a gradient that needs to be straightened, you can use it for the same thing. So let's change the scale to 1:2000. Now we're going to pick essentially all the SP points that are in obvious shales at this large scale, and it's going to move the shales to be 0 millivolts. This means that you can use 0 millivolts to the actual value as an estimate of clay content, and you can also use it as an estimate of RW, which is one of the primary uses of the SP curve. It makes it a lot easier. So we just work our way down, Points are entered as little black dots. They can be deleted by tapping on the point a second time, and that deletes them. So now we're going to change back to a slightly bigger scale so that we can see more. So 1:500, and we're just going to go through and refine our SP correction. So here we have the refinement. So as we work our way down, we're selecting points that are in shales, and basically bringing the SP curve to be 0 millivolts in the shales. The next thing we do is we process it. So as soon as we hit the process button, it presents the SP curve. We can rename it anything we want, and that's shifted it and saved it back to the file. So the next thing that we need to do is to just essentially export the data as a LAS file, which we can now use in any other sort of data set. So we basically select the top menu, hit export, and then we select save as LAS file. We want the default logs, and if we hit on logs we can actually select the logs, but we can see here that all the logs there are selected, and then we hit OK, and it will present a menu for present the normal dialog box for saving, and we just select where we want to save it. And it's saved. And that's pretty much it.